All right, we are back. Unit 2, day 7. We are going to be talking about some difference of perfect cubes. We've been talking about polynomials all this time. We've talked about roots, we talked about their graphs, we talked about factoring, and so forth. We talked about division. All right. Now, if you haven't noticed, in our warm-ups, we've been factoring and reviewing the factoring from math 1 and 2. So I want to continue to do that with this warm-up as well. And this will kind of wrap up all the review as far as the factoring. And we're going to get into a different type of factoring today. That is the one that's for math 3. Okay, so here we go. If you know how to factor some of these, go ahead and factor them. If you don't, you can follow along. I will use Desmos for some of them to check them and so forth if you need that. But here we go. For this, x squared minus 17x plus 60. All right, so here we go. There's nothing out in front. So what are we looking for? Factors of 60 that add to negative 17. All right, well, I know, let's see, 6 and 10. Well, that adds to 16, not 17, so not that. Let's see, I know 2 and 30, but that's not going to work. That's like 32. All right, well, some of you may have already found it. 5 and 12. 5 goes in there 12 times. That gives us, whoops, 17. However, notice you want a negative 17. So what do? We switch our signs. So we need x and then a negative 5 and then x and negative 12. Now, again, if you're struggling with this type of factoring, just know we need to be able to do it quickly. We can go to Desmos right quick and we can put this in. Again, guys, anytime we do anything on Desmos and you need it, you need to practice with us. All right, here, as long as you can find the x-intercepts and they're nice. If they're not nice, you cannot do this. Here we go. We got 5 and we have 12. All right, so remember, do the opposite, x minus 5, x minus 12. All right, here we go. Let's look at the next type of factoring. Now, this next one's not as easy because it's not just x squared. All right, so we can do 12 times negative 2, which is negative 24. All right, factors of negative 24 that add to 5. All right, some of you may know this. Some of you have to play along and just like go through all your different factors. But one thing I know that, let's see, 3 and 8. But if this is a negative number, one of them needs to be negative. So if I just throw it on the 8, 3 minus 8 is negative 5, but I want a positive 5. So switch our signs, negative 3 and positive 8. Now, please do not write x minus 3, x plus 8. That is not how this factors. Because there's something out in front, we rewrite the first, we rewrite the last, and then in between, we take this negative 3 and put an x with it. We take the 8 and we also put an x with it. And we're going to group it. We're going to group the first two, and then we group the last two. Here, what's the GCF that pulls out of this first group? It's 3x. All right, so that leaves us with 12 divided by 3 is 4, and we took an x away. Negative 3 divided by 3 is negative 1, and we took that x away. So that's just a minus 1 right there. Now, what's the GCF that comes out of this parentheses? 8x minus 2. All right, so let's see, 2 comes out. All right, so I'm going to pull out a positive 2. And so 8 divided by 2 is 4x. Negative 2 divided by 2 is negative 1, which look at their parentheses, they're the same. Okay, so whatever we pull out in front, the GCFs we put together. In the parentheses you see twice, let's write it once, like that. All right, now, if you're struggling with that, that is a little bit harder factoring than number 1. We can go to Desmos, and we can plug this in. All right, so if I plug it in, it was 12x squared plus 5x minus 2. Now, this one's not as easy. Okay, so this is the one that's going to be a little kind of weird. And some of you may not understand this. All right, now 0.25, you should know what type of fraction that is. All right, you got to write these as fractions. So x minus 1/4. Okay, we don't like, oops, you can't see my paper. All right, we don't like the fraction. So remember what we can do is we can do like this. So this must be the factor. All right, now to get the other factor, if you don't know how to write this as a fraction, you can use that division. You're going to have to use long division. You can divide this into the 12x squared plus 5x minus 2. That's one way to factor. I'm not going to do it. I'm just telling you what you can do. Or realize this. Now, Desmos always rounds to 3 decimal places when you're using the North Carolina one. All right, do you know what 0.667? Really, this is negative 0.66666 repeating. As a fraction, that is 2/3. So we're going to do the opposite, x plus 2/3. All right, so quickly, you can take this 3 and put it out in front, 3x plus 2. All right, so if you knew how to write that as a fraction, then great. And look, we got the same thing now. All right, if you don't know how to fraction, again, the 1/4 you can get, or the 0.25 you can get as a fraction of 1/4, and then put the 4 out in front. Then divide, use long division. And when you use long division, you should get 3x plus 2 as its factor. All right, so that's a way that we can do it right there. All right, now, what about x squared minus 4? You're like, oh, no idea how that is. Now, this is a special type of factoring, although some of you may have already plugged it into your calculator. X squared, okay, minus 4. And if you remember anything from number 1 or even number 2, look at their roots, -2 and 2. So if I know -2 is a root, then what do I know as a factor? X plus 2. All right, if I know 2 is a root, then what's the factor? X minus 2. Guess what? I factored it. I'm done. My degree is 2, so at most I have 2 roots, which I found them, so therefore 2 factors. All right, now this is a perfect square. If you remember perfect square factoring, okay, you got to recognize perfect squares. If you have, and I'm going to write a squared minus b squared, okay, and it's actually difference of perfect squares. Okay, difference because it's minus. This only happens when it's minus. We'll talk about something when it's plus in a second. If it's minus, then, and you recognize both of these are perfect squares with a minus in the middle, you would take the square root of a squared, which is a, and put it in the 2 parentheses at the front. All right, and then the second one is b squared. Take the square root of b squared, which is going to be b. One's a plus, one's a minus. It doesn't matter which one's which. And that's how it factors. So here, think about it. The square root of x squared was x. So x and x. Square root of 4 is 2. 2 and 2. One's a plus, one's a minus. Now, you may be asking what happens when it's a plus. Well, guess what? If you see 2 perfect squares, but there's a plus in the middle, it's prime. We cannot factor it. That's what prime means. Okay, so let's go on to number 4. What do you recognize about number 4? Yeah, these are both perfect squares. 9 is a perfect square and x squared is a perfect square. All right, so think about this. When I take the square root of 9x squared, well, think about what's the square root of 9? That's 3. What's the square root of x squared? X. So 3x, and I put it in both of these parentheses. Okay, now, square root of 1. Well, 1 is always a perfect square. It's actually a perfect anything. Square root of 1 is 1. All right. And then one's a plus, one's a minus. All right. As long as you can recognize perfect squares. Now, you could try to find that the roots. Now, the problem with these roots, and you'll see it in just a second. All right. When I do 9x squared minus 1, yes, it does cross. But do you see how this is negative 0.333 repeating or 0.333 repeating? All right, so that would be like 3x, or no, not 3x, sorry. That would be like x minus 1/3. As long as you recognize 0.333 repeating is 1/3, you can do it this way. You can take this 3 and then put it there. You can take this 3 and put it out in front. And look, you would get the same thing as above. Now look at number 5. What are you thinking? Well, if you're thinking perfect squares, you're incorrect because 2 is not a perfect square. And here's how you can tell. You can take a calculator and you can say, all right, square root is down here on my keyboard of 2. And I notice, oh, this is a decimal. Like square root of 4, you can, if you didn't, whoops, hold on, that's wrong. Okay, square root of 4, you can, I'm having all problems with this. Square root of 4, there we go, is 2. Or if I entered and I'd said square root of 9, notice how these don't come out as decimals. They're perfect squares. They come out as whole numbers. That's how we know it's a perfect square. All right, these both are not, but what do you recognize? Now, what should you always look for? If you said GCF, you're correct. A 2 comes out. All right. And 2 goes into 32 16 times. Now look at it. X squared and 16. Those are both perfect squares. If you need to check the square root of 16, here you go. The square root of 16 is 4. So here, keep the 2 on the outside. Square root of x squared is x. Square root of 16 is 4. And plus or minus. Now, again, if you try to factor this right here using Desmos and you put in 2x squared minus 16, I mean, not 16, minus 32, you'll see that negative 4 is a root, so it'd be x plus 4. You'll see positive 4 is a root, think opposite, x minus 4. The only thing you're going to miss is the 2. You have to recognize a GCF of a 2 comes out, or you can do GCF of 2 and 32, and you can see that it's 2. All right. You can also double check if you put a 2, x minus 4, and then x plus 4, is it the same graph? And here, that is, if I pick off the green, I can see the red underneath. So therefore, I factored it correctly. If I take the 2 off, you'll see that there's 2 different graphs, and it's not the same thing. All right. Now, what about this one right here? All right, I recognize it. Oh, perfect squares. So a lot of you are going to start going like this. You're going to say, okay, square root of 49x squared is 7x. All right, square root of 81 is 9. So plus minus, is that correct? No. Why not? Because that is a plus. And we said when it's 2 perfect squares with a plus, no GCF pulls out, it's going to be prime. It cannot be factored. We can also throw this into our calculator and say 49x squared, all right, plus 81. And we'll notice that this graph doesn't cross the x-axis at all. When I start zooming, there you go. It's up here. It doesn't cross the x-axis. All right, and we're going to be talking about those coming up tomorrow or the next day or today in our lesson. All right, so let's go on with our lesson today. We're going to continue and we're going to do U2 day 7, sum and difference of perfect cubes. All right, now the first thing I'm going to start out, let's factor this completely. Now, did I give you a factor of this? No. All right, so let's start off. If we don't know how to factor that, let's go ahead and start doing this right here. X cubed, all right, minus 8. All right, well, wait a minute, I do see a root. What is it? 2. So what's a factor? X minus 2. Well, what I can start doing is I can start dividing by x minus 2. All right, let's use synthetic division on this. If I'm dividing by x minus 2, what goes in the box? Think opposite. It should be positive 2. Now, I have to be careful what I write down. All right, notice I have x cubed, so I need a 0x squared. And then I need a 0x. Now I have my constant, so I'm good. All right, so now when I write down those, my coefficient here is 1, so make sure you put a 1, and then 0 for the x squared, 0 for the x, and negative 8 for the constant. All right, put a line. If you know how to do this, pause the video and please do it. All right, synthetic division, we bring down our 1. 2 times 1 is 2, and now we add these, so that's 2. 2 times 2 is 4. And again, we add these, and that's 4. 2 times 4 is 8. And I should be getting 0 because I found from Desmos that x minus 2 was a factor. Now, let's write this right here. Okay, if this x to the third, then this is x squared, and this is x. Now, I don't have any minuses, so I'm going to put a plus. So here, our question was, or they want us to factor completely. Well, x minus 2 is a factor, and right now I'm seeing x squared plus 2x plus 4 is a factor. Now, let's see if we can factor this even further. There's nothing out in front. So are there factors of 4 that add to 2? Well, the only factors of 4 are 2 and 2. So that gives me 4, or 1 and 4, which gives me 5. It doesn't give me 2. So there's no other factors. So guess what? This is the way it factors. Okay, so let's go look at the next one. All right, x cubed plus 125. All right, so let's go and let's go plug this in. All right, x cubed this time, it's oops. All right, plus 125. Sorry, not 25. All right, I do see it crosses once. Now, how many roots could I possibly have? I could possibly have 3 because that degree is 3. But here, if I zoom, you'll notice that there's only one. All right, there's only one root, and it's at -5. So if -5 is a root, what is a factor? Opposite, x plus 5. All right, so what can I do with it? I can divide with it. Now, I'm going to use long division just so we can see it again. X plus 5. And remember, we still need to check for zeros like we did here. X cubed, well, I don't have x squared, so I need 0x squared. Then I need 0x and then 125. All right, so x cubed divided by that x is x squared. Make sure you put it up top. X squared times x is x cubed. All right, x squared times 5 is 5x squared. If you didn't put that 0, you would definitely can tell here that you would need it. Now remember, we're subtracting, so I have to distribute that minus sign throughout. I like to do it in a different color. All right, these cancel because one's positive, one's negative at the same thing, and this equals -5x squared. Make sure you're getting the signs correct. Now bring everything else down. Now -5x squared divided by that x. All right, that leaves me with -5x. All right, so -5x times x is -5x squared. -5x times 5 is -25x. All right, change your signs. All right, the first one gets in, or cancels, sorry. And then here, this is 25x positive. All right, we need to do it one more time. 25x divided by that x right there, and we get 25. Okay, so 25 times x is 25x. 25 times 5, if you go and do the math, is 125. Now we change our signs. All right, these cancel, and also these cancel, so it should equal 0. And because we knew that x plus 5 was a factor, it should. Now, to factor this completely, look what we got. So we had x plus 5, now we got x squared minus 5x plus 25. All right. So that's one way to factor these. All right. And these are actually perfect cubes. All right. Well, what is a perfect cube? Now, if you're trying to figure out, okay, perfect cube, I don't know my perfect cubes, it'll be okay. You can actually throw numbers in. Well, where is that here? Okay. So hit your keyboard. And then if you go over the functions, now this is square root down here. So I have to go to functions over here. And if I do, and I keep scrolling, and you may want to scroll slowly, don't do it too fast, you will start seeing, let's see, right here. Okay, it looks like a square root, and then it's got an N. All right, when you hit it, you see that's already up here. Well, you could put a 3 there for cube root, and then arrow down. And if you're trying to figure out numbers, okay, what's a perfect cube? 2. All right, now if I back it up and I put 125, that's also a perfect cube. We're going to look at those in just a second. But if you ever recognize perfect cubes, there is a way that it factors just like the difference of perfect squares. All right. Now, notice we did use division on this in our Desmos calculator, and we were able to factor these. Because here, and I didn't say this doesn't factor any further. Factors of 25 that equal -5 doesn't happen. It stays like this. Well, I want you to notice these are very similar right here. All right, we got some sign differences though, but notice we had some sign differences in the beginning. Now here's how it factors. Okay, if I notice x cubed minus b cubed, or I notice a cubed plus b cubed. All right, now this works with both minus and plus, unlike the square thing. All right, these both factor. As we saw here, we factored with a minus, factored with a plus. Now this is how it factors. It's going to come into 2 parentheses. Do you know how recognize these 2 parentheses? The first one has 2 things in it. The next one has 3 things. All right. Now, you would take the cube root of the front one. All right. That would be a here. Okay. Put them in both. I'm going to deal with signs afterwards. Now, just take the cube root of b cubed. Don't worry about the minus or the plus. The cube root of b cubed would be b. All right. Now I just want to focus on A and B. All right, now listen to what I say for this. This first one, you're going to square the first term. Ignore this right here. I'm just looking at A and B. When I talk about first term, I talk about A. So I'm going to square this first term. So that's A squared. All right. Now, the middle term right here is both of these multiplied together. So just A and B, A times B. And then this last term is these terms, the last term squared. So B squared. Okay, now as far as signs, look at what we start with. This one starts with a minus, so I'm going to start with a minus here. This one starts with a plus, so I'm going to start with a plus here. If you actually notice how it started with a minus here. When it factored, it started with a minus. Here, when it started with a plus, it started with a plus. All right, and now what we do is now the next sign is always the opposite. Okay, so if this one's a minus, this one's a plus. If that's a plus, that's a minus. And then the last sign in both of these, look at what the last sign is. Didn't matter what it was always a plus. So do a plus right here. All right, so that's how it factors. Okay, now let's look at this. As far as perfect cubes, okay, what if you don't know your perfect cubes? Let's just run through some of those right quick. All right, so I want you to turn to page 229 in your workbook. All right, and it looks like this. It's this bridge thing right here. Now they've done the first one for us. 2 cubed equals 8. All right, so 125. If you actually go back to Desmos, look, the cube root of 125 was 5. All right, so just think, cube root 125. So basically 5 cubed is 125. All right, you go figure it out for 27. All right, so remember, if you need this again, hit functions, but I'm just going to do this right here. All right, so it's 3. So what that means is 3 cubed equals 27 right here. All right, if you want to try the rest, go try it. Okay, I'm going to do them in just a second. All right, so 64. Okay, back it up. I'm going to put 64 in. Look, 4. So we're going to put 4 cubed equals 64. All right, the next one was 1,000. So I'm going to put 1,000 in. Well, what is that? 10. So 10 cubed equals 1,000. And now 216. All right, is 6. Okay, so 6 cubed equals 216. Now, this isn't all the perfect cubes. All right, this is just getting you started. Okay, so just know that right there. Okay, so let's go back to your sheet of paper and let's actually use our method of factoring. Now, you can continue like we did on 1 and 2. And if you don't know how to factor these, like using the method that I'm about to do or don't quite understand it, then just graph this. You'll find 1 root and use division. All right. But if you actually memorize this method up here, it'll be a little quicker than the actual division. Okay, so here we go. The cube root of x cubed is x. The cube root of 27, we just found 3 cubed is 27, so it must be 3. I'm not going to write signs yet. All right, now this first one, you always take the first term, just look at the x and 3 now. I'm going to ignore the x cubed plus 27 for right now. You take this first term, you square it. You take both of these terms and you multiply them together, so 3 times x. And then you take the last term and you square it. Well, what's 3 squared? 3 squared is 9. Now, as far as the signs, it starts with a plus, so this starts with a plus. This is the opposite, so that's a minus, and the last one's always a plus. All right, so let's go do the next one. All right, well, what was the cube root of 8? All right, cube root of 8 was 2, and the cube root of x cubed is x. Well, what do you remember the cube root of 125 is? Well, that was 5. All right, so here we go. Now we square the first. When we square the first, I'm talking about you got to square the 2 and the x. All right, so that's going to be 4x squared. All right, now for the middle term, we multiply 2x and 5 together. Well, when I do that, what does that give us? 10x. And then this last term right here, we square the last. So what's 5 squared? 25. Now let's put the signs in. So if you start with a minus, you should start with a minus. All right, here, the next one's the opposite, so that's a plus, and then the last one's always a plus. All right, if you think you can do the others, go do the others, okay? Now, if not, keep following along. These are both perfect squares. 64 is a perfect square, 8 is a perfect square. All right, so here we go. Okay, the cube root of 64 we found earlier was 4, and the cube root of x cubed is x, so that's 4x. Cube root of 8 is 2. All right, so square the first, so 4x squared. All right, and that gives us 16x squared. Make sure you're squaring the 4 and the x. All right, now the middle term is basically these multiplied together, 4x times 2, so that's 8x. And then the last one, you got to square the last. So we're squaring 2, which is 4. All right. Now, if that's a plus, this is a plus. All right. The next one's the opposite, and the last one's always a plus. Now, some of you are going to move on to number 5 and think you're done. You're not actually. I want you to keep looking at those parentheses. And what do you notice? Do you see that a 2 comes out of both of these? So that makes 2x plus 1. Do you see how a 2 comes out of each? Actually, more than a 2. Do you recognize a 4 comes out? All right. And here, when I take a 4 out, that's 4x squared minus 2x plus 1. All right. And lastly, what I can do is the two GCFs I pulled out, I can multiply together and I get 8. Now, what I want you to look at is I want you to look at the original problem. Do you see this 8 right here? Couldn't I have pulled out 8 to begin with? So it'd make 8x cubed plus 1. All right. If you can pull out that to begin with, it's actually better, okay? Because now these numbers are smaller. And this here, the cube root of 8x cubed is 2x. The cube root of 1 is 1. All right. And then what I would do is I would square the 2x and it gives me 4x squared. I would multiply 2x and 1 together and I get 2x. And then I would square the 1, which is 1. All right. And then I would put all my signs in. Okay. Now, so just be careful about GCFs. They can happen anywhere. You can pull out in the beginning in this one, or you can pull out in the end. All right. And it still works. Now, in some cases, you may have to pull out in the beginning and then you have to pull out in the beginning, but you couldn't pull it out in the end because it wouldn't work otherwise. All right. I'm going to keep going. Again, we've got perfect cubes. I just put these here to practice. So x cubed minus 64. Cube root of x is cubed is x. Cube root of 64 is 4. All right. If you need to look on page 229 that we did, you can for those. Now take the first one and square it. So that's x squared. The middle is these two multiplied together. So 4x. And then the last one we square, and that's 16. All right. Now, as far as the sign, you start with a minus. This is the opposite. This one's always a plus. Double check, there's no GCFs, and there aren't, so we're good. All right, and then the last one. Now, I know the cube root of 125 is 5, and then we have x, but I don't know what the cube root of 364. I think that's a perfect cube, but let's try it. All right, so here, the cube root of 343, yep, it's a perfect cube, so it's 7. All right. We square the first, so 25x squared. Okay, we multiply these two together, so 7 times 5x is 35x. Whoops, I didn't put the 5 in. All right, and then we square the last. All right, and as far as signs, it starts with a plus. This is the opposite. That's always a plus. All right, you got it? All right, if not, again, you can always graph these, do what we did in number 1, and find the first factor and then divide using synthetic or long. It just might take a little longer, all right, to do that. Okay, so let's go to page 232, activity 3. All right, so here we go. All right, Andre was given the expression 2x cubed plus 250 and told to find the factor form. Andre graphed the polynomial in Desmos and noticed only one zero. Puzzled, he exclaimed, this cubic polynomial only has one zero, but I don't see any numerical perfect cubes in the expression. Could there be a sum of perfect cubes hiding in this expression? Now I want you to look at it. Well, we know 2 and 250 are not perfect cubes, but we've talked about this, and we talked about this, and let me look back in number 3 just a second ago. All right, GCF pulls out, a 2 pulls out. All right, if I take a 2 out, it's this right here. And didn't we see this earlier? We saw this earlier in number 2. Okay, here, the cube root of x cubed is x. The cube root of 125 is 5. All right. However, we square the first. All right. We multiply these two together and we square the last. That's going to give us 25. This starts with a plus. This is the opposite. And then this one is a plus right there. Now, as far as when they were talking about Desmos right here, we can plug this in and you can see that, let's see, it was 2x cubed, all right, plus 250. There we go. Sorry about that. Okay, and when we zoom out, you can see that Andre only saw one root, so -5. So we know x plus 5 is a factor right here. You can divide, all right, but when you divide, you're going to get a different polynomial from this, but always look for GCF. A 2 would factor out of it, and then you would end up with the same factors. So that's also possible of that. All right, and let's go to number 4 down here, same page down here on the bottom. What's the remainder? Okay, May thinks that x plus 2 is a factor of x cubed minus 8. She started using long division to find the second factor. Complete the long division, decide if May is correct. Is x plus 2 as a factor? Well, remember when we started talking about factors, what has to happen, especially when we go do long division? If you want to do synthetic, you can. I'll just stick with long just to practice long. And they started it for us. Okay, so here they put our zeros in. Great. Okay, they started to divide. So here, the x cubed divided by x gave us x squared. That's how they got that up there. So x squared times x is x cubed. All right, x squared times 2 is 2x squared. All right, subtract. All right, so here these cancel. Oh, and 2x squared plus negative 2x squared, those cancel. So that's just 0x squared plus 0x minus 8. Now, you can continue with x squareds, but you're going to notice 0x squared divided by x is just going to give us 0x. If you want to write that up there, you can. All right, and then just keep going on. 0x times x is 0x squared. 0x times 2 is 0x. And then subtract. All right, notice these cancel, notice those cancel. But you don't have to, you don't really need that, okay? Because all that is 0. What if we just go to the -8? Well, I can't divide that by x because it leaves us in the denominator. So this must be my remainder. All right, so really we would do -8 over x plus 2. Well, the question is it a factor? It's not a factor. Okay, so x plus 2 is not a factor. And the reason is my remainder did not come out as 0. Now, you could factor, or you could go to Desmos on this and see that, let's see, if I would plug in x cubed, all right, minus 8, I would see that, wait a minute, the root is 2. So really, what is a factor? It's x minus 2. You can divide by that and you'll figure out what the other factor is. Okay, it'd be x minus 2. Or if you actually recognize this, this is a perfect cube right here. All right, here, the cube root of x cubed is x. Cube root of 8 is 2. Ignore the minus sign for right now. Okay, I would square the first. I would multiply those two together. And then I would square the last. And if this is a minus, this is the opposite. That's always a plus. All right, that's really how that factors. X plus 2 is not actually the factor. And we could have verified that also through Desmos like we just did. All right, so don't forget all your different factorings that we have. Okay, I also have these right here, down here. So let's finish off with these three problems. X squared minus 4. All right, that's a perfect square. We actually did it in the warm-up. Okay, so remember, square root of x is x. Square root of 4 is 2. One's a plus, one's a minus. So that's perfect square. All right, look at this. That's also a perfect square. All right, what's the square root of 36? X squared, it's 6x. What's the square root of 1? So one's a plus, one's a minus, doesn't matter which one's which. And that's how that factors. So that's just perfect squares. But what about this right here? Well, what do you recognize? Well, we did 343 up here, and that was a perfect cube, but 25's a perfect square. You can't mix perfect squares and perfect cubes together. Also double check, does a GCF pull out? No. So this one's prime. This is not possible. All right. You do need to be familiar with factoring, especially if you're in the honors class and you're moving on to AP Pre-Cal and AP Calculus. Those are things you definitely need to know how to factor and factor without a calculator. All right. We did use a little bit of our calculator to help us factor some in the beginning, but we could use division. We did cover how to factor a perfect cube. So especially if you're in the honors course, you got to be able to know how to factor a perfect cube without a calculator. All right. We've covered all the factoring now to this point. So make sure you're familiar with it. We covered the rest of it in the warm-up today as well. If you need to factor some more, ask your teacher for extra help with it. You can also go Google factoring and so see extra videos that other people may have of it as well. All right. So thanks for listening today. And we have another day coming up with polynomials.